Okay, this is the project reference angles. So if we look here real carefully, we can see that the figure shows an angle of 152 in its standard position, right? Measure counterclockwise. Show that the reference angle means by drawing a reference angle and calculating its measure. Well, first off, if this is 152, that means our reference angle will be this little angle right here. All right, so how do we find that? Well, very simply, if here's our starting point and all the way across is 180, and that much of it is 152, the reference angle will simply be 180 minus what? 152, which turns out to be 28 degrees. So the reference angle will happen to be 28 degrees in this quadrant 2. Well, what happens right here in this one was in quadrant 3? Sketch the reference angle and calculate its measure. Well, I want to say this here. The reference angle always goes back to your x to make that happen right there. So if it's 250 all the way around and right here is 180, well, here if I would take 250 and minus 180, this reference angle turns out to be what? 70 degrees. Okay? So what I want to do now is this. It says you should have drawn the arrows and the arcs for the reference angles in your problems 1 and 2. If you haven't, draw them now. So like there'd be my little, there's my alpha angle. Already had that one drawn right there. Explain why the arc for 152 degrees from the terminal side to the u-axis. In other words, how come it wants to know both these go back to the u? How come, this question is asking, how come we didn't do this? How come we didn't do that there? Because it's closer, but it doesn't make it right. And the reason that we don't go there, that we always go back to our x, is this reason here. Because if we do that and we make a triangle out of this angle here, if this is our angle, this side is always the adjacent. The x, what that does is it makes the x is always the adjacent. And then what this does is it means the y is always the opposite. And here the y would be the opposite. So the reason that we always drop back to the horizontal axis is so that x will be adjacent, which simply means then that we can use the x for the cosine feature, especially on the unit circle, and y is always opposite, so that we can use it for the sine function on the unit circle. That's the reason why that it does that. All right, let's see what question 4 says. And I may have kind of answered 4, all right, with that explanation. Amos thinks the reference angle for 250 should go back to the y-axis because the terminal side is closer. So Thomas Y's conclusion does not agree with the definition of the reference angle we had in problem 1. Well, it's kind of like right here. Because if we do that, then if we do it the way that Amos says it, then what would happen here is this. This would be my adjacent, and that would be my opposite, and then we can't use, that would be y, and this would be what? X. So the reason it doesn't work is kind of the opposite. Then our trig values won't work. The reason is, for the answer for number 4, is then we can't use them for our trig values. The trig values will not work. Trig values will not work that way. All right? Pretty simple. Forward. All right, let's look at what we have for question 5 up here. All right. Sketch an angle at 310 in standard position and find its reference angle. Okay, so let's do this here. So if here's our starting point, well, if I kind of go around, there's 90, 180, 270, 360. So 310 is going to probably be somewhere about like there. But that's not correct until I what? Draw my angle like that. Okay? But it says find the measure of the reference angle. Well, if we make this a triangle right here back to our x, here's our reference angle. Well, how do I find that one? Well, how far is it? It's 360 all the way around, and we used up 310, so how far is that from? I'm just going to subtract it. Turns out to be what? 50 degrees. So my reference angle is 50 degrees. That's what he wants to know on this one. Well, that's not too hard. On number 6 is sketch an angle whose measure between 0 and 90. Well, let's just make up something, kind of split it right here, and we'll just call that 45 degrees. So what's the reference angle? Well, see how it's in quadrant 1? I'm going to draw my line straight back to here, my angle right there. Guess what? It still is what? So whatever this angle is in quadrant 1, that is my reference angle. Wow! Pretty cool. All right? Now I'm going to roll the screen up just so I kind of got 7 and 8 on the problem here together, because they're going to kind of go hand in hand. So I'll put 7, 8, 9 up here so we can kind of finish up our work. So here we go. Problem 7 shows a point 2 units from the origin on the terminal side of the angle. Oh, let's go back up here. So I said, this shows my negative 150. Find the reference angle. Well, here we go. I always go back to my x. So here we go right here. Well, here's what I'm going to look at. I'm going to kind of ignore the negative. It's 150 from here to here. And all the way to there is 180. So it's just 180 minus what? And kind of like my, so the reference angle is what? 30 degrees. So this angle right here is 30. The alpha angle, or reference angle, is 30 degrees. Okay? So in problem 7, we show a point 2 units from the origin, the terminal side. Draw a segment for this point perpendicular to the u-axis, which I did, forming a right triangle whose hypotenuse is 2 units long. Knowing what we know about geometry is find the lengths of 2 triangles, or what we talked about with Sheldon Cooper for those who have been in class. This is my hypotenuse. This is my side opposite. This is my side adjacent, correct? So if this is the hypotenuse, this is a 30, 60, 90. This is twice as long as this, so this would be 1. And this would be what? Square root of 3, or square root of tree sometimes, like I like to call it. So that's kind of what we did here. So if you just look at the triangle itself, which I should probably draw right here, we have a 2, we have a 1, and we have a square root of 3. But the problem is, that's what we have up here, right? But in these quadrants right here, notice, what would this x be? It would be what? Negative? And that would be negative. So really what I have is what? A y value that's negative and a value there that's negative. That's what that's forming about. Its net values would be the same, it's just that they're negative to indicate the direction. So that's how we can use these reference angles in a sense to find the trig values of sine and cosine, and it's how we use alpha angles. So don't forget, tell me what you learned personally by watching this video to answer your question right here. And that is part of the project. Hope you learned something. Thank you. Thank you very much.